is the two-column proofs, example A. Example A. You're going to become a master teacher of this particular problem, so pay very close attention to the process that's used. I'd like you to walk your classmates through a similar process. First, we're going to walk through GIF. That's why you're not even looking at the proof. Really, all the thinking is done in this process. Step 1, we're going to read the given and mark it on the diagram. And we see we have segment QS, which is this whole segment, is equal to segment TU, which is this whole segment. We'll put hatch marks there. And we're also told that segment RS and TR, RS and TR are of equal length. And we're being asked, in this scenario, if you know those two segments are equal, how do we know that the QR, which is from here to here, and RU are equal? So that's our given information and what we implied. Implied and freebies, there's really not any freebies here, but one thing that's real simple here that's implied is the fact that the larger segment, QS, is made up of these two segments. So we know segment QS is made up of the segments QR. Let me color code this so it's easy to spot this. We know that the blue segment, QS, is made up of the segment QR, the red one, plus the green one, which is RS. We know that the larger segments is equal to the two smaller segments added up. We also know TU, the same thing, the larger segment, is equal to the smaller segments added up. So TU is equal to RU plus the other segment, which is TR. So it's implied if we know that these are equal, and we know that these are equal, then of course these are equal, and that's what you're trying to prove. So all we have to do is write everything up. That it's kind of obvious if you have a large segment that's made up of two smaller segments, the smaller segments are equal and the larger segments are equal, then the leftover segments are equal. These would be the, if you will, leftover segments, if we were to subtract them, of course. So let's utilize this information to actually walk through a proof. Okay, so we're going to start with the fact that QS and TU are equal. And we know that because it is given. That's the big blue segments. And we also know that the big blue segments is made up of the two smaller segments. So I'm going to write this. I know that QS is equal to the smaller segment, QR, plus this smaller segment, RS. And why do we know that? That's just called segment addition, which means smaller segments add up to bigger segments. We also know this other large segment, TU, is made up of its smaller segments, which is RU, plus T to R to T, or T to R. That's also called segment addition. Now, it gets a little confusing when you have all these letters here, so watch very closely. Do you see it? We have TU here. And do you see that we have TU here? And you see we have QS here and QS here. Notice that should read, yes. So notice we have pink and yellow, that's equal. If the pink and the yellow are equal, then you can substitute this for each of those. So we're going to substitute QS, and we're going to substitute TU. So we're going to take this segment and use it as a scaffold. So we replace QS with this. So we have QR plus RS, and we replace TU with this right here. So what we did is we took that segment QS and we replaced it with what it adds up to, and we placed this TU with that, and that's called substitution. Okay, now let's look what we're also told is equal. We were told that the greens are equal, so we're going to take that, RS and TR, and we're going to put it right here. We have RS is equal to TR, and why do we know that? It's given. So now here's another connection. Do you see RS? And do you see TR? See how those are interchangeable? So we're going to swap one out and put the same one on both sides. It really doesn't matter which we swap out. So I'm going to have QR plus RS equals RU. And now I'm going to swap out the TR with RS. Because I can. Now I have RS the same on both sides. And again, that's called substitution. Now look at our target. Our target is to get those red segments equal. Our target, look at our target. Our target is to get those red segments equal, which are right here and right here. Notice we now have the same thing on both sides, which is RS. So I can subtract RS from both sides, and that gives me what's left over, which is QR and RU now being equal, because this cancels. And that is called subtraction property.